So now that we've talked quite a bit about aggregate operations, both the intermediate ones and the terminal ones, broadly, and give you kind of a high-level view of stuff, we're going to start diving into different examples of these operations, starting with the intermediate operations related to map and mapToInt. And what's interesting about all this stuff is that these operations we're going to cover apply nicely for both sequential and parallel streams. And in fact, one of the great things about learning sequential streams is you become a better parallel streams programmer because it's so darn easy to switch from sequential to parallel just by changing the factor method you use to create the stream. So everything here will translate into what we're going to really cover in earnest when we get to the parallel streams portion here in a bit. This particular example will continue to showcase our simple search stream program where we're looking for the do-re-mi words in the do-re-mi song. Remember that intermediate operations are always lazy. And what that means is they don't do a darn thing unless and until a terminal operation is reached. And again, you'll understand exactly why that is the case when we look at how the implementation works under the hood. So let's start by talking about map and mapToInt, which should be familiar to you because those are two operations in your programming assignment. These are both stateless run-to-completion operations. So what map does is it applies a mapper function that takes every element in the input stream and applies the mapper and returns an output stream consisting of the mapped results. And the thing to remember about map, very important to remember, the number of elements in the output stream should always match the number of elements in the input stream, unless, of course, an exception is thrown. But let's ignore that. So unless an exception is thrown, then it'll terminate. But if that doesn't happen, it'll map. And, of course, also if there's no short-circuit terminal operation. So those are the two things to keep in mind. But we're going to focus on the case where we have something that will process everything in the terminal operation and there's no exception. So the caveats here apply to all the run-to-completion intermediate operations. So I'm not going to keep saying this thing over and over again. Just remember that if exceptions are thrown or if there's short-circuiting terminal operations, then they won't process everything, but otherwise they do. So here's an example from the simple search stream program of applying map and a mapper function. So this is the map intermediate operation, which works on the stream of search words. And for each search word, we're going to search for the word. And that's going to determine the indices, if any, where the word that we're looking for appears in the input stream. So that's what map does. And as I mentioned before, transformations may occur. Doesn't have to occur, but in this case, it does occur. So we are going to go from a stream of strings to a stream of search results. This is what the code actually looks like in more of a code-centric view. And notice, as always, we have this wonderful fluent interface style where we connect these things together by using the dot operator. It's not really an operator, but using dot to call the method as it cascades through the pipeline. So that is map. Very simple, very straightforward, very, very common. Let's talk about a little variant of that called mapToInt. And when you watch the frequently made mistakes video, you'll see that a common mistake, not a mistake, but a common thing to do better is to forget to use mapToInt instead of using map. And so you'll see that there's a nice, easy way to solve that if you watch the video. So this particular example is going to be based on mapToInt. And what mapToInt does is it returns a so-called int stream consisting of the results of applying the given mapper function to all the elements of the input stream. So if you have an input stream, then mapToInt is applied to every element. And int stream is just a specialization of stream for the int primitive. And the reason why we have to do all this gobbledygook stuff with Java is because there's this concept of reference types and primitive types or native types. And in Java, those are two different type systems. Other languages get around this. I think Python, for example, gets around this by just not distinguishing between primitive types and reference types. They just have reference types. But Java, for a bunch of historical reasons, has both. So we have to work with kind of this dual hierarchy of things. In practice, it's not as confusing as it seems when you try to describe it for the first time. As with map, the output of mapToInt should match the number of elements of the input to mapToInt. So in this case, however, it's always going to be int. You're going to have a stream of ints coming out of mapToInt. And the way we're going to use it here, and we'll see this when we look at the code a little bit later, there's a method that we're going to use to print stuff. And in this particular case, we're going to take a list of result objects, which keep track of where the indices occurred for the various words that we found. And we're going to convert that list into a stream, and then we're going to apply mapToInt, passing in a method reference where we're going to end up with a stream of ints coming out of this. And then we're going to do some stuff to it. So notice here that mapToInt transforms whatever comes in, which in this case is a stream of result objects. It's going to turn it into a stream of primitive ints. And of course, the reason we're going to do that here, as indicated very succinctly, but we'll look at this in more detail when we look at the code, is because what we're doing is we're taking this list of search results.result objects. Each result object keeps track of the index where the word was found in the input string. And we're turning that results list into a stream. And then we're going to go ahead and use mapToInt to just get back from that a stream of indexed locations as primitive ints. And we're going to use that stream of locations as primitive ints to find the max. So max is a cool little terminal operation that is used on a stream of primitives, like ints or longs, and it'll find the max, and it'll return either an optional that has the max, if there is in fact anything in the stream, or if there is nothing in the stream, if for example we have an empty stream, max returns something called an optional, and an optional is a very funky, cool little specialty class in Java that either has got a value or not. And it's a way of getting rid of null pointer exceptions. And so if max returns an empty optional, then we're going to have to say return or else 0. So if it's empty, then or else returns 0. Otherwise, if max is not empty, or else returns whatever the max was. And we'll talk about that a little bit later. That's a little bit confusing at first, but it's necessary because it's not guaranteed that all streams have anything in them. And again, notice the fluent programming style with cascading method calls. So that's the end of the discussion of map and mapToInt.